brim off with the deburring tool. It kind of digs into the plastic, so I used one that was made for softer materials like aluminum or bronze. We have several different deburring tool bits, but so I got it off, and just wanted to show you how easily this slides in, or slides over rather. So we'll go right up in here, and you can see now the anti-rotation feature. Maybe. Anyways, it's got a little bit of play. I kind of expected that. It's not that big of a deal. So I like that. Pull that off and do this one-handed. You can see how the air drill goes down in there. It just falls right down in there. So I've now got a way to bolt the flange down. So this thing will look like this. I'm going to go put all the hardware in now and bolt it down, and we'll go from there. Installed, no problems. Looks good. I knew that the additional pieces of hardware weren't exactly necessary, but I knew it would have a pretty cool effect in the end. So you can see that I got the socket head cap screws plus the washer is counterbored all the way down through there, and then the hex nuts dropped in nicely. I just did I think I did 15 thousandths, 10 or 15 thousandths offset all the way around so that it would slide in nicely, and it does. It's a pretty good little fit. It's slip fit at the very least, probably more than that. So good to go there. Flip it upside down here. You can see the air chuck is inside there, no problems. Hardware slid in nicely. Haven't tightened everything down yet. I will once I get it on our spindle on our router, but everything seems great. One thing that I added is a hole to be able to get to the air inlet, and a hole on the other side for the exhaust to come out. Something I tried to do, and I guess I got it pretty accurate, is if I can show this with my finger, but I can swivel this around back here, and that's how you get it in and out. And then once you get the air chuck up inside there, it just barely clears the hole. You can see clears the edge of the hole right there, and swivels into place. So we just need to attach some air to it, and then we can test it out. So I'm going to go put it on the spindle now, and should be good to go. Mounted here, and looks good. Pretty strong, for what I got at least. Tightened it so that the gap all the way down was pretty uniform, and overall I'm pleased with it. I think it's going to give us exactly what we need. And so I've got a little bench test here. Of course, what I'll do when I plumb this up is I'll have the air hose come out here and probably have it run up through here, and then up our Z-axis, and then across the gantry, and then maybe down over here, and just have a quick disconnect. But for bench testing, I just wanted to kind of show what we plan on doing. We plan on maybe having a little quick chart that says so much pressure is so many RPMs, and we'll do that with, of course, a digital tack and some reflective tape just to test it out. But so I'm gonna plug our little air line in here so we can do a bench test. There we go. Of course, with my regulator here. I'll be able to adjust RPM. So yeah, I'm pleased with it. I think it's going to work. And I think that this will allow us to be very versatile with our machine and be able to do low RPM drill methods. Of course, when I run the G-code, I won't have the spindle plugged in, or we'll just simply turn the spindle off with the G-code. I'm not sure exactly how I'll do that, but it'll be pretty easy. So then, of course, I'm just relying on X, Y, and Z of the machine here. And then the drilling operation will just be maintained in the air drill. This may not be good for drilling hundreds or even thousands of holes, just because the air maybe isn't the most efficient method, because the compressor will be kicking on every few minutes probably. So, but for drilling bigger holes in our hybrid mill/router that we have here, I think this will be good. So thanks for watching.